The miasma theory held that diseases such as cholera, chlamydia or the Black Death were caused by a miasma, a noxious form of bad air, also known as night air. The theory held that the origin of epidemics was due to a miasma, emanating from rotting organic matter. The miasma theory was accepted from ancient times in Europe, India, and China. The theory was eventually displaced in the 19th century by the discovery of germs and the germ theory of disease. Etymology: the word miasma comes from ancient Greek and means pollution. The idea also gave rise to the name malaria through medieval Italian. Views worldwide. Miasma was considered to be a poisonous vapor or mist filled with particles from decomposed matter that caused illnesses. The miasmatic position was that diseases were the product of environmental factors such as contaminated water, foul air, and poor hygienic conditions. Such infection was not passed between individuals but would affect individuals within the locale that gave rise to such vapors. It was identifiable by its foul smell. In India, there was also a miasma theory, and the Indians take credit for being the first to put this miasma theory into clinical practice. The Indians invented pan, a gamba paste, that was believed to help prevent miasma. It was considered as the first anti-miasmatic application. This gamba tree is found in southern India and Sri Lanka. In the 1st century AD, the Roman architectural writer Vitruvius described the potential effects of miasma from fetid swamplands when siting a city. For when the morning breezes blow toward the town at sunrise, if they bring with them mist from marshes and, mingled with the mist, the poisonous breath of creatures of the marshes to be wafted into the bodies of the inhabitants, they will make the site unhealthy. The miasmatic theory of disease remained popular in the Middle Ages, and a sense of effluvia contributed to Robert Boyle's suspicions about the hidden realities of the air. In the 1850s, miasma was used to explain the spread of cholera in London and in Paris, partly justifying Haussmann's latter renovation of the French capital. The disease was said to be preventable by cleansing and scouring of the body and items. Dr. William Farr, the Assistant Commissioner for the 1851 London Census, was an important supporter of the miasma theory. He believed that cholera was transmitted by air, and that there was a deadly concentration of miasmata near the River Thames banks. The wide acceptance of miasma theory during the cholera outbreaks overshadowed the partially correct theory brought forth by John Snow that cholera was spread through water. This slowed the response to the major outbreaks in the Soho district of London and other areas. The Crimean War nurse Florence Nightingale was a proponent of the theory and worked to make hospitals sanitary and fresh-smelling. It was stated in notes on nursing for the labouring classes that Nightingale would keep the air the patient breathes as pure as the external air. Fear of miasma registered in many early 19th century warnings concerning what was termed a unhealthy folk. The presence of fog strongly indicated the presence of miasma. The miasmas behaved like smoke or mist, blown with air currents, wafted by winds. It did not simply travel on air, it changed the air through which it propagated. The atmosphere was infected by miasma, as diseased people were. Many believed miasma was magical, and was able to change the properties of the air and atmosphere completely. Contagionism versus miasmatism. Throughout the 19th century, the medical community was divided on the explanation for disease proliferation. On one side were the contagionists, believing disease was passed through physical contact, while others believed disease was present in the air in the form of miasma, and thus would proliferate without physical contact. Two members of the latter group were Dr. Thomas S. Smith and Florence Nightingale. Thomas Southwood Smith spent many years comparing the miasmatic theory to contagionism. To assume the method of propagation by touch, whether by the person or of infected articles, and to overlook that by the corruption of the air, is at once to increase the real danger, from exposure to noxious effluvia, and to divert attention from the true means of remedy and prevention. Florence Nightingale. The idea of contagion, as explaining the spread of disease, appears to have been adopted at a time when, from the neglect of sanitary arrangements, epidemics attacked whole masses of people, and when men had ceased to consider that nature had any laws for her guidance. Beginning with the poets and historians, the word finally made its way into scientific nomenclature, where it has remained ever since. A satisfactory explanation for pestilence and an adequate excuse for non-exertion to prevent its recurrence. The current germ theory accounts for disease proliferation by both direct and indirect physical contact. Miasma in China. In China, miasma is an old concept of illness, used extensively by ancient Chinese local chronicles and works of literature. Miasma has different names in Chinese culture. Most of the explanations of miasma refer to it as a kind of sickness, or poison gas. The ancient Chinese thought that miasma was related to the environment of parts of southern China. The miasma was thought to be caused by the heat, moisture and the dead air in the southern Chinese mountains. They thought that insects unregistered trademark waste polluted the air, the fog, water, and the virgin forest harboring a great environment for miasma to occur. In the descriptions of ancient travelers, soldiers, or local officials of the phenomenon of miasma, fog, haze, dust, gas, or poison geological gassing were always mentioned. The miasma caused a lot of diseases such as the cold, influenza, heat strokes, malaria, or dysentery. In the medical history of China, malaria had been referred to by different names in different dynasty periods. Poisoning, psittacosis, and acclimatized were also called miasma in ancient China because they did not accurately understand the cause of the disease. In Sui dynasty, Dr. Cao Yuanfeng mentioned miasma in his book on pathogen and syndromes. He thought that miasma in southern China is similar with typhoid fever in northern China. However, in his opinion, miasma is different from malaria and dysentery. In his book, he discussed dysentery in another chapter, and malaria in a single chapter. And he also found that miasma caused different diseases, so he suggested that one should find apt and specific ways to resolve problems. The knowing of the concept of miasma can be separated into several steps. First, before Western Jin dynasty, the concept of miasma was gradually forming. At least, in Eastern Han dynasty, there was no character of miasma. In Eastern Jin, large amounts of northern people moved toward south. Miasma was recognized then in the group of men of letters or nobility. After Sui and Tang dynasty, scholars bureaucrats traveled and were sent to be the local officials recorded and investigated the miasma. As a result, the government became concerned about the severe cases and the causes of miasma by sending doctors to the area of epidemic to research the disease and heal the patients. In Ming and Qing dynasty, the addition of the local chronicles record the different miasma in different places. The northern boundary of the distribution of miasma were at first Kunling Mountains and Urai River in Han dynasty, then, Daba Mountains and Yangtze River in Sui and Tang dynasty, and Nanning Mountains in Ming and Qing dynasty. Nowadays, in the 20th century, miasma occurs only in inland mountains in China. However, southern China was highly developed in Ming, Qing dynasty. The environment changed rapidly, and after the 19th century, Western science and medical knowledge were introduced into China, and people knew how to distinguish and deal with the disease. The concept of miasma therefore faded out, due to the progression of medicine in China. The influence of miasma, sanitary engineering reforms in the West. The theory of miasma disease made sense to the English sanitary reformers of the mid-19th century. Miasma explained why cholera and other diseases were epidemic in places where the water was undrained and very foul-smelling. As sanitary reformer unregistered trademark S engineering leader, Londonly unregistered trademark S Edwin Chadwick, put it, oil smellers disease the theory led to sanitation improvements, such as preventing the reflux of noxious air from sewers back into houses by separate drainage systems in the sanitation designs, which incidentally led to decreased episodes of cholera, and thus helped to support the theory. The miasma theory was consistent with the observations that disease was associated with poor sanitation and that sanitary improvements reduced disease. It was not consistent with the observations of microbiology, however, that led to the later germ theory of disease. The introduction of medical bacteriology in the 1870s and 1880s provided a challenge to the miasma theory, though consensus was not reached immediately. Concerns over sewer gas, which was a major component of the miasma theory developed by Galen and brought to prominence by the Great Stink, led to continuing proponents of the theory, who observed that sewers enclosed the refuse of the human bowel, which medical science had discovered could teem with typhoid, cholera, and other microbes. Even though later disproven by the influence of bacteria and the discovery of viruses, the miasma theory helped make the connection between poor sanitation and disease. This caused public health reforms and encouraged cleanliness, which led to the legislation of the Parliament, which approved the Public Health Acts of 1848 and 1858 and the Local Government Act of 1858. The latter of these confers the power of instating investigations into the health and sanitary regulations of any town or place, upon the petition of residents or death rates exceeding the norm. Early medical and sanitary engineering reformers included Henry Austin, Joseph Bazalgette, Edwin Chadwick, Frank Forster, Thomas Hawksley, William Hayward, Henry Leatherby, Robert Rawlinson, Sir John Simon and Thomas Wicksteed. These and later British regulatory improvements were reported in the United States as early as 1865. Years later, the influence of these sanitary reforms on Britain was described by Sir Richard Rogers. The miasma theory did contribute to containing disease in urban settlements, but did not allow for a suitable approach to safe excreta reuse in agriculture to be adopted. It was one of the causes for abandoning the prevailing practice of collecting human excreta from urban settlements and reusing them in the surrounding farmland. Such resource recovery schemes were common in many European cities until the 19th century before the arrival of sewer-based sanitation systems. Throughout the 19th century, public health, sanitation and the influence of miasma became the main reasons to cremate. The miasma theory believed that infectious diseases were spread by noxious gases emitted from decaying organic matter, which included decaying corpses. This public health argument for cremation faded along with the miasma theory. The influence of miasma, in southern China, the terrifying miasma diseases in the southern regions of China made it the primary location for relegating officials and sending criminals to exile since the Qing Han Dynasty. Poet Han Yu of the Tang Dynasty, for example, wrote to his nephew who came to see him off after his banishment to the Chao prefecture in his poem, En route, the prevalent belief and predominant fear of the southern region with its poisonous air and gases is evident in historical documents. Similar topics and feelings toward the miasma-infected South are often reflected in early Chinese poetry and records. Most scholars of the time agreed that the geological environments in the South had a direct impact on the population composition and growth. Many historical records reflect that females were less prone to miasma infection, and mortality rates were much higher in the South, especially for the men. This directly influenced agriculture cultivation and the Southern economy, as men were the engine of agriculture production. Zhou Curfew, a local magistrate from the Nansung dynasty, described in his treatise, Representative Answers from the South. The men are short and tan, while the women were plump and seldom came down with illness, and exclaimed at the populous female population in the Guangxi region. This inherent environmental threat also prevented immigration from other regions. Hence, development in the damp and sultry south was much slower than in the north, where the dynasty's political power resided for much of early Chinese history. From miasma to germ theory, although the connection between germ and disease was proposed quite early, it was not until the late 1800s that the germ theory was generally accepted. The miasmatic theory was challenged by John Snow, suggesting that there was some means by which the disease was spread via a poison or morbid material in the water. He suggested this before and in response to an epidemic on Broad Street in central London in 1854. Because of the miasmatic theory's predominance among Italian scientists, the discovery in the same year by Filippo Pacini of the bacillus that caused the disease was completely ignored. It wasn't until 1876 that Robert Koch proved that the bacterium Bacillus anthracis caused anthrax, which brought a definitive end to miasma theory. In 1846, the Nuisances Removal and Diseases Prevention Act was passed to identify whether the transmission of cholera is by air or by water. The bill was used to encourage the owner to clean their dwelling and connect them to sewers. Some years later in 1855, John Snow made a testimony against the amendment to this bill that regularized air pollution of some industries. He claimed that, at the same year, William Farr, who was then the major supporter of the miasma theory, issued a report to criticize the germ theory. Farr and the committee wrote that, the more formal experiments on the relationship between germ and disease were conducted by Louis Pasteur between 1860 and 1864. He discovered the pathology of the puerperal fever and the pheogenic vibrio in the blood, and suggested using boric acid to kill these microorganisms before and after confinement. By 1866, 8 years after the death of John Snow, William Farr publicly acknowledged that the miasma theory on the transmission of cholera was wrong, by his statistical justification on the death rate. See also, night air, germ theory of disease, references. External links, prevailing theories before the germ theory, cholera theories, term definition.